Hello everyone. So I welcome you all for our 6 days advanced medical imaging workshop. You all are connected for this workshop. You enrolled for this workshop because we do have a common interest, that is to understand medical imaging, to interpret medical imaging problem statement, to identify the problem statement which we get from the interpretation, and we have to devise the solutions for that. And in solutions we have to apply deep learning pre-trained models. We have to include some mechanism in it which will give us better results. And then we have to evaluate our models to check the results which we have obtained. This is overall related to medical healthcare in diverse issues, because here I have listed 10 problem statements related to healthcare, and ultimately the goal is to have some research oriented work. Okay, so it's not only about the project building. You have to generalize here in context of research, because AI is now helping a lot in medical field also. And as you are seeing on the list, I have included many problem statements like chest x-ray, spine x-ray, Parkinson disease, skin cancer, bone fracture. There are many problem statements are mentioned here. What we are having with these problem statements, we will be available with data related to it. What kind of data we are available with? Sir, images data we are available. Okay, because when we go to doctors for diagnosis, the doctor recommend, okay, come on, do have an x-ray, then only we can understand what is the problem you are facing. Either the doctor will recommend CT scan, MRI. There are many, you know very well know about this thing. And then when the report comes, then the doctor see the report, okay, this is the x-ray and this is the solution given to you. uh, there are such problems, okay, then he will write the medicine or the further treatment. What will happen if we automate the task? Why? What is the reason? The reason is because it may happen that few things may be skipped from the eyes in analyzing the report, in analyzing the images. Okay, so if we want to have deeper interpretation, then what can be done and how AI is going to help for that? In that aim, by performing understand of medical imaging, by analyzing medical images, by developing solutions, by applying transfer learning, by evaluating our models. These are our learning objectives. And what we expect from this workshop after 6 days, what do you come out by attending this workshop for 6 days? What will be the expected outcome? So, the expected outcome will be you can analyze such kind of problem statements, such kind of data. That's what you can do. You can pre process such kind of data very easily. You can build deep learning models. You can use pre trained models. You can change the architectures. That's what you can do. You can apply attention mechanism. That is something which I have incorporated. And I have released a lot of projects by adding this attention mechanism. What it is, I will explain. And obviously, applying all these things over the models, training the models, you are going to get the results. We can evaluate these results. And the last thing is we can have the collaborations related to real world medical imaging projects, research. If you do have a problem statement, because I know many people who have joined this workshop, they do work in this particular field. They might be the PhD aspirants, or they have some other goal or the idea. Okay, so we will together combinedly join to solve such problems, and I will be helping you. Okay, so that's what has been decided by me in this workshop. Now, let me share another screen. Now, can you see the word template here? Is it visible to everyone? Fine. In case if you have any difficulty, please let me know at the same time. All right. So let's talk about medical imaging. Okay. Medical imaging. As I have already introduced that because of some healthcare problem, we do visit to the doctor, and doctor suggest or recommend that you have to perform this for like report to diagnose ahead. So medical imaging is a technique to visualize, okay, to visualize the internal structure and functioning of human body. We want to see what is happening inside our body, because our body is also like an ocean. What is happening, what is the reason, what is the cause? See, doctor can understand the symptom, but for better treatment he should be knowing what is happening inside. So if we can use some technology, like there are many ways. We can have x-ray, we can have MRI, we can have CT scan, we can have ultrasound. Okay, there are many more. With this, we can look inside, visualize inside human body to see bones, to see brain, muscles, to detect injuries, cancers, to monitor pregnancy or abdominal issues. There are many things which we can do by using this technologies. Okay, got it. So these technologies comprises of image data. Obviously, the images will be recorded. All right, and they will be behaving as a data, as a record for the treatment history. And on the basis of that record only, whatever comes in that record, the treatment will be given. So if I do talk about medical imaging in 2024, well, AI has been helping a lot. It has been introduced too much to detect the patterns in the data, image data, hidden patterns. That's what the machine learning means. That's what the deep learning means, to identify the hidden patterns in the data. See, something which a human can't see, that can be detected by AI. So by using machine learning, deep learning algorithms, by using the libraries, by using the framework like TensorFlow, PyTorch, there are many frameworks, Python programming. Okay, it provides a support. Healthcare has been boom. The use of AI in healthcare. Okay, and this is so much enhanced in terms of precision, speed, accuracy, accessibility. Okay, and if I do talk you about the figures are the investment of AI tools and the technologies in healthcare. It may rise from $762 million in 2022, and it will raise to about $14 billion to 2032. So in 10 years, this much hike. Okay, so definitely that's the reason, that's the goal. We all are here. And there are so many applications of AI in medical imaging. You can use, I already told you, in radiology. You can use in early disease detection or prediction. Lot of people do consult me for this regards only. It's not only to the human beings, that's related to plants also. Okay, we can diversify these things to agriculture also. Yes, okay, we can have personal treatment plan. We can predict disease. Prediction systems are there. Also, you are seeing right now wearable technology. Okay, that means which can identify the heartbeat rate, okay, pulse rate, something like that. Okay, so that is also there. Research and development, R&D has always been there. So if you ask me, sir, what do you think about AI? I only think about this R&D only, research and development. It's not only about seeing the YouTube video tutorials of someone. No, not at all. Just finishing the YouTube video tutorial of someone. No, not at all. It's about something new which you can contribute. If you are in this direction, then only you are doing right, else you are not doing right. It's not just to finish the title or the topic. It's like some to think something new, to identify the problem and to contribute. So this workshop is for contribution. This workshop is not for me, not for you. It's for us, it's for society. How we can come up with a solution for a particular problem. And it's not like that, sir, you have already prepared, so you will be delivering the lecture according to that. No, it's two-way communication. This is Google Classroom, Google Meet. You can unmute and you can say, you can ask. But with I told that if that is something valid. Okay, so if I do talk about the data, because we'll be taking the X-ray images, MRI images, ultrasound images, we'll be having the data in that format only to perform the analysis. Because what is data science? Data science means exploration of data. What is machine learning, sir? Using algorithms over that data. What is deep learning, sir? A subset of machine learning, sir, where we are having huge amount of data. Then, sir, what is generative AI, sir? Okay, generative AI is to generate the data over which the models have learned. Now it's time for the model to generate something, because the models have learned a lot. They should generate. So that is generative AI. However, we are not dealing with the gen right now. We're dealing with the deep learning models in this particular workshop. Okay, so how this scenario is made, like this is your data, you give the data to the machine. In machine, you do have algorithms, you do apply algorithms, and there will be a training. And once your training has been done, okay, here the training has been done, you can use that model to perform the prediction. Okay, algorithms, what these algorithms are? Maths. Simply, I will say maths. So, those who are good in maths, those who are good in stats, they are the winners of data science, machine learning, deep learning, generative AI, whatever. Everything, everywhere is maths. Python, it's a programming, it's a coding language. We can use to implement our projects, we do the coding, but maths. Okay, if you have to devise some solution, you know how to write the equations for it. Okay, so data. We are having images data here. What is an image? You know, oh, sir, image is, sir, sir, it's made up of pixels, sir. What are pixels, sir? Pixel are picture elements, sir. Okay, elements. Okay, these picture elements, they comprises of information, sir. That means we can have an image, and this image is made up of pixels, sir. These are the pixels. Okay, which comprises of information. These are having, sir, intensity, sir. That is called as intensity. They do have intensity. Okay. Right now, the example which I'm showing you right here is raster, raster scan, raster images. Raster images, they are composed of pixels which are arranged in grid. Here you can see a grid. This is a grid, rows and columns. So you can have a pixels arranged here like this. Okay, and the common file format are, you very well know, JPG, PNG, BMP, GIF. There are, okay, many file formats which we usually use. We are having other file format also for the images, like vector images. We do have vector images also. So in this case, there are mathematical formulas rather than pixels, storing images in form of mathematical formula. Such images are called as vector images, like extension SVG, PDF. Okay, we are having 3D images also. We are having medical images like MRI, CT scan, X-rays. They are stored in form of like DICOM, DICOM, this format, DICOM format. So what is this DICOM format? Okay. See, DICOM means digital imaging and communication in medicine. This is the full form of DICOM. It is a standard format which can be used to store, to transmit, and to view medical imaging data. And it is widely used in radiology and other fields of image generation like X-ray, MRI, CT, ultrasound. Okay, so such kind of data, DICOM, it comprises of both actual image along with the information. Some information also it consists of. For example, like patient information, age, gender, whatever. There are certain. Okay, so we are having this thing. Along with that, imaging parameters also like exposure time, resolution. They are also present. And here the file extension is like .dcm. This is the file extension for TICOM. Okay, fine. So that's what I want to tell you related to medical imaging. We are having binary images, we are having thermal images. Okay. However, in general, what you see while working with the images available to you, you will see that, sir, we are having grayscale images, sir. We are having, sir, color images. Okay. You may also heard about this thing, digital images. Sir, what these are, sir? These are some of what, and sir, black and white images. Then what are black and white images, sir? Most of the people now do confuse between images only. Okay, so let me tell you, grayscale images are the images which represents the shades of gray. Shades of gray. Okay, where each pixel is having an intensity from 0 to 255. 0 stands for black and 255 stands for white. However, there are intermediate values also. So it's a range of values from 0 to 255. People do have the confusion related to black and white, related to grayscale, related to color scale. Okay, so grayscale images 0 to 255. That is the numerical value representation for the pixels. Okay, and it's stored in 8-bit format. So if you want to show 0, 8-bit means what? 0, 0, 0, 0, 0, 0, 0, 0. This is 8-bit. Okay, and what will be 255 then? Then 1, 1, 1, 1 is something like that. It's been something like that. Okay. So it's 8-bit representation. We can have intermediate grayscale range values also. We do have color images also. Color means RGB, red, green, and blue. Their combination will make the colors. Again, they also range from 0 to 255. Each channel. So here the colors are represented as channel. We are having three channels here. Three. In grayscale, we are having only one channel. In color, we are having three channel. Okay, like this. This is a channel. RGB. Three channel. Okay. 8-bit each. Okay, and the total number of possible colors here are 16 million. This much colors we can make using RGB, three channel, and we can combine these colors. We can have digital images also. So, what these digital images are? Digital images are the images which are in the form of 0 and 1. Okay, 0 and 1. Digital images. Okay, that means those images which are stored on digital devices. We are having the cameras, digital camera, that's what you say. Okay, these images, digital images can be grayscale, they can be colored, they can be binary. So this what I'm showing you now, this is binary. So I can have black and white. This is binary. Black and white images are binary images. Okay, fine. So this is about the images. Now let me share the entire screen now. Okay, and we'll discuss more. So keep on listening to me, and if you have anything to say, you can. If you have any doubt, okay, fine. Now next. So sir, right now you have told about the data. Is my screen visible? I have switched to the new.
Yes, sir.
Okay, fine. So far we have talked about the data. That means images. I have told you about different kind of images. Okay, and such kind of format will be available to you for the analysis. Let me tell you one thing. See, if you take a data, image data, that will be like for X-ray, that also a grayscale. If you take MRI data, grayscale. If you take ultrasound data, grayscale. So mostly the data is in grayscale. That means they are representing the information in one channel. One channel information they are representing grayscale, which ranges from 0 to 255, black to white. This information is being present in the one channel. So grayscale images are preferred images for medical imaging. Okay, but sir, you told about sir RGB also. Yes, I told. And sir, if you have seen my code, which I did share of so many problem statements, I converted this gray into RGB. There is a reason. Okay. Okay. Initially, you have a data in grayscale. One channel, less complex. Okay. If you are having a one channel, then it's less complex. But when you convert this one channel into three channel, into colored format, RGB, then you are adding two more channels here. Okay. So isn't it complex? Yes, it's complex. That means, sir, you are converting gray into sir RGB. Will it happen, sir? Let me tell you one thing. No. The kind of information initially an image is having, that is gray, that will remain. However, the same information will be projected on here also and here also. That means the same information is projected here, here, and here. Same information. Now the question is, sir, why you're doing this thing? Why you're converting this gray into RGB, sir? Let's interpret by gray only, na? Yeah, you can. You can perform the analysis by gray only. But what is the reason? Why you did this thing? See, the reason is because for medical image diagnosis, I am going to use pre-trained models. What is model? Model. So machine learning technique. That's what you call as a model. Machine learning technique. It's an AI model. AI. So, sir, pre-trained model. That means that's already trained. You are saying that something which is already trained over images. That's what you are going to use. Ah, yes. I'm going to use that, which is already trained on images. Okay. So, is it, sir, necessary? No, it's not necessary. You can create your own architecture. Either you can take a pre-trained model, this given architecture, but if you make your own architecture, yes, not an issue. You can. We do this thing. So, sir, what is the benefit in using pre-trained? The benefit is pre-trained models are models which are already trained over huge amount of diverse images. They are already trained on images. Okay. They have a knowledge. They already have a knowledge about images. They are trained over different category of images of humans, of animals, of different objects, different classes. They are already trained. So we do extract the knowledge from them. Okay. And we apply this knowledge to our data. Okay, by adding some layers. Okay, by adding some layers, few layers we'll add, and then we will apply this knowledge to our data, and then we train the model. And while training, only these layers parameters will be adjusted. Okay, so taking the knowledge from the pre-trained model is called as transfer learning. Okay, transfer learning. So we have transferred the knowledge. Okay, fine. For yes, yes, please ask the question. Just please ask the question. For grayscale, black and white are is extreme of grayscale. Yes, 0 and 1. Extreme of grayscale and comments in grayscale 256 values, typically 0 to 255. Yes, obviously. Yeah. Any doubt, please ask the question.
Hello, sir.
Yeah, please say.
So when are you going to start the Google Colab?
Google Colab right now, I will be talking about the images, this pre-trained model introduction. I need to talk about CNN, convolution neural network. Okay, the basic maths.
So from the project itself, you can explain. You can
Hmm? Uh,
you from the project itself, you can
the
explain from there.
project,
It'll be easy because the session is getting very boring, and
is it?
we have our time commitments for other things as well. Yes.
Is it for all?
Yeah,
No,
definitely.
sir, it's fine.
No, it's fine only, sir. Being from a medical background, sir,
No,
everybody
it's
is
fine,
sitting
sir. It's fine.
not
No,
the same
sir, it's
space which we
fine.
have talked about.
It's fine, sir.
Because the most of the people here they want to listen from the basics. They want to go like from the basics. Okay, directly
Mm,
starting a coding part is
I
not
can
feasible.
understand. I can understand, sir. But uh, sir, the thing is, you have shown 10 projects,
So, sir, it's
and
not
out of
say
that 10
ten
projects,
projects.
if
I
you
know
can,
how
you have
the
given
ten
6 days of
projects.
time.
The 10 projects, sir. It's my
Mhm.
responsibility. Now, how I'll finish the 10 projects. I know what's common in them, and the common thing is the coding part. Okay.
No, what I'm saying is,
Hmm.
if you can guide us with the collab thing, it'll be more beneficial to us. It'll save our time and it'll be more interactive.
Sir, I will in the first session. I need to talk about the basics, elementary part, and then I will be switching to the project. And in project also, I will be explaining the code. But in code, when I pick up an architecture, for example, I pick up VGG16, I need to explain that architecture. So, sir, it's not only the coding. I need to explain the architecture, how that architecture is built. and how it is performing, what layers are introduced, what is the mass applied inside the architecture. Okay, so sir, just running the code and that's.
So the same thing you can explain. No, no, not running the code. You have already run the code, so it will be easy for you to show it to us what you have done. What is your how much time you have dedicated to actually do the coding part. You can actually guide us how we can do all these things in a structured way, because when we are actually trying to do projects, we need some such kind of motivation. So that I'm trying to say, sir.
So sir, that will
I
take a
mean,
bit
I'm not
time.
saying you should not teach basics. You should definitely teach us.
So that will take a bit time because I can't go ahead with the projects directly. I need to explain what I have
So
committed.
can you tell me when I can expect
See, today
when I can expect? That
I
is
need to
what I'm asking,
explain what
because
has
today
been.
day one you have shared 5 files.
Hopefully, see,
Yeah,
today I
you
need
have
to
shared five
explain.
files.
Uh,
So what is the timeline I'm asking?
See, let me tell you one thing. Today, I need to talk about this pre-trained, what we are doing, what different images data set over these pre-trained models are being trained. I need to talk about CNN layer, which is being used in the architecture. What is convolution neural network? Because the people want to listen. What is the CNN? What is the formula used in the CNN? Because in the code, if I do write CNN, then they should understand what is CNN. Okay, they need to understand what is CNN. Okay, so I can't directly show the code, I can't directly show the implementation. Okay, this has been there, and no. Let me first build the basics for them, and then we can
Mhm.
go ahead. Okay, so I need to tell what
Sure,
I'm going to use. So first, they should have the knowledge
sure.
what I need to use. Okay, so I'm just preparing my
Okay, sir.
path. Is that right, everyone?
Yes, sir. Totally,
Yes,
sir.
fair enough, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir. Yes, sir.
From
We are with
basics, I
you.
would like to understand from basics.
So I need to prepare the path.
Yes, sir. Yes.
All right. Okay. Yes, Snehal ma'am, you have some question. All right. Fine.
No, no, sorry, it was by mistake.
Okay.
Sorry.
All right. Fine. Fine. So keep on listening to me. All right. So I was telling about pre-trained models because at least you should know what we are going to use. Okay. So pre-trained models are the models, as I already told that are prepared, that are trained on huge amount of data, images data. So we do have benchmark data. That data is of images data, which is having millions of images present in it, millions of images present in it, and different category images, as I already told you above. So over this images data, such models, some such architectures are trained. Okay, because the question, the query being asked, it's very fair. I'm very much fair. The query asks, sir, you can directly jump to the coding part. See, do you know what layers we can add? Do you know what layers we can add? Do you know how many layers we can add? What they do? What result they give? Do you know? In deep learning, it's all about skills. I'm not teaching machine learning where you are already having a regression model, you are having a classification model. No, I'm not teaching machine learning. Machine learning models are simple statistical mathematical models. They are already clear. But in deep learning, you requires a skill, that how many layers you want to add into building an architecture. The most of the people present here, if they want to relate the things with their phd, they want to relate their things with the research paper publication, they are looking here for novelty. Sir, we want to do publication, sir. What architectures you have used, you have to explain, and what layers, how they perform, that's what we need to explain, and that will be explained by showing the projects what I did. I will show the projects, entire thing, but let me make the platform for that. Okay, yes, Sarthak.
Yes, you talked about creating an architecture if you don't want to use a pre-trained model. Is there any way, like if there are some images or some kind of a project that we want to use our own architecture to make
Yes,
for
yes,
future?
yes. We'll use our own architecture also. We'll use our pre-trained also. Okay, we'll build our own architecture based upon the CNN. That's what we are going to do.
It's because in your like in your notes that you gave us before the meeting, you told us the PyTorch and TensorFlow,
Uh-huh.
right?
Uh-huh.
So
TensorFlow.
in this live project, would we be creating our own architecture for this?
Yes, yes, CNN. That's what I'm saying, Sarthak.
Okay, sir.
Okay, creating our own architecture means that's what I'm saying. How you can incorporate the layers. That's what I'm saying. How you can add the layers. What is architecture development? You have to add the layers now. Okay,
Yes, sir.
so I'm explaining. I'm moving ahead to approaching to that only. Okay, so yes, any other doubt? Please let me know. You are open to ask.
Sir, one question.
Yes.
So, if there are pre-trained models already there, so
Yes.
what we need to do from our end?
Sir, research never stops, sir. And the pre-trained models are been there. However, in pre-trained models, what I have incorporated is attention mechanism. Okay, fine. Attention mechanism. I am extracting the knowledge from these pre-trained models. Okay, once I got this knowledge from these pre-trained models, then I told that I'm going to add layers ahead. Okay, I'm going to add the layers ahead. In that layers only, I need to add multi-head attention. What it is, you have to be patient with me. Okay, then I will be able to explain this thing, attention mechanism. Because you know that right now we are having all these LLMs, everything, they are based upon attention mechanism. Okay, that chat GPT and everything. How we can use this technique, this phenomena with the imaging. That's what I want to tell. And obviously, I need to show the entire thing, the results which I achieved by using this thing. And it's not only that, sir, just simple pre-trained you are going to. I'm going to add some more layers which will be beneficial for you to get results. There are some more layers also which I can add. I will be developing my own architecture also, not pre-trained, not only the pre-trained. I can build my own architecture also, incorporating the certain layers, and then I will show you how I get the results. So there are many things to learn about. Okay, got it. Fine.
Yes, sir.
I
Thank you.
have a request, Nirmal.
Yes,
sir.
yes, ma'am.
I make a request that you allow people to ask questions in the later part of the
Okay, fine,
presentation, because you are in a good flow, and right now somebody just comes in and with a question and the flow is lost, and again we come back and then somebody just, because you will surely answer their questions in the process, and that's our request. Let them stay muted, and then you give a last 10 minutes of
Yes,
whatever
yes, sir.
that is there, and then that's a positive feedback. And
Yes,
I
yes.
just feel that you are going in a good flow, and
Yes, yes,
maybe
sir.
if you need to, you can show some pictures which can help us understand. That's okay if you don't have. We can just go with the flow. That's just my request, because for a person who's trying to get the flow of what you're saying, it is very much distracting. And people can be hurt and they can just drop off for now and then come back later if they are ahead. So that's one of the, or they can keep muted and just keep listening. That's my recommendation. And thank you very much for taking my request. And I see people are supporting my request. Thank you.
Thank you, madam. So that's a good suggestion. And if you have any doubts, you can ask at the end. You can note those things. All right, fine. And you can talk to me personally also. No worries. All right. So, yeah, I was talking about the data and the models both. Okay. So, data, that means images, I was telling. We are having already benchmark data images, and I hope if you have heard about the names like ImageNet, you have heard about the name Coco, common objects in context. Okay, that is also a benchmark data set. We are having Pascal VOC, visual object classes. There are many data sets available. Okay. However, the mostly used data is ImageNet and the Coco. That's what we have seen. In the pre-trained models, I have seen ImageNet data. ImageNet is a benchmark data, and over this benchmark data, it is comprises of 1.2 million labeled images, which is having 1000 object classes. Okay, it's a 1.2 million images data, 1000 classes, different categories data it is available with. So your pre-trained models are trained over this data. Okay, and these pre-trained models are good enough to classify this 1000. See how much strong these models are, that they can classify 1000 images. Okay, if overall 1.2 million images are been given for the training purpose, fine. And Coco, that is common objects in context, it comprises of 330,000, this much number of images, and they are having 80 category or 80 classes. And I have seen this kind of data in object detection. For example, if you know about YOLO, so in YOLO version, Coco is used. Okay, so according to the perspectives, these data sets were used. Okay, we are having other benchmark or reference data set also, like open images data. We are having cityscapes also. We are having LFW, that is labeled faces images data. We are having KITTI. There are many benchmark data sets available. Okay, and ImageNet data, that is what we are in concern of, because your pre-trained models are being trained on this data. In pre-trained models, we are having so many wide range of models available, like VGG, Visual Geometry Group, and 16 and 19, these are the versions. We have the outdated older versions also. You know how the things get started. Things get started related to images when there is a breakthrough with the CNN, convolution neural network. The breakthrough started from here because of this. Okay, because of this technique around 2010. Okay, this might be the year when the concepts of CNN came into the picture. Okay, and on the basis of this CNN only, we do created the pre-trained models, like they're trained. Okay, these architectures were built. So VGG is Visual Geometric Group. It's an architecture which is having 16 layers, 19 layers. Okay, this is VGG 16 or VGG 19. These are the two architectures, okay, which are sequential in nature. The layers are arranged sequentially. So 16 layers are there, 19 layers are there. Okay, we are having other architectures also, like Inception, V3, V4. We are having ResNet, that is residual net. We are having exception. We are having efficient net. We are having dense net. We are having so many architectures available. Okay, so VGG 1619 are sequential convolution. ResNet is having skip connections. That means, okay, we are here, these layers, and then we are giving a skip connection. This skip connection you can see also in the architecture of transformer for LLMs, large language models. I do teach generative AI there. You have skip connection. If you see the transformer architecture of LLM, GPT, generative pre-trained, Inception, the previous versions were like Google Net. Okay, Google Net. So this inception, it is having multi-branch convolutions. Some parallel arrangements are there. In efficient net, you do perform scaling, compound scaling. Scaling is related to width, height, depth. Okay, so we do balance depth with resolution, achieving higher accuracy on lower computational capabilities. DenseNet, that means the dense connections between the layers to improve the flow and the reuse features. So that is your DenseNet. Okay, we are having these pre-trained architectures in different like versions, as I already told, 16, 19 for the VGG, Inception, V3, V4. Okay, now we are having efficient net, we are having E0, E1, E2, E3, E4, E5, E6, E7, all these. These are E7 is the big model, E0 is the light model. Okay, so many versions are there for that. Okay, and all of these architectures were tested over the benchmark data. So if you guys are in a research, you have to prepare your architecture and you have to test your architecture over the data. That's what you have to do. So sir, how we are going to build up the architecture, sir? What's the theme here? Okay, so the theme is you should know about CNN, convolution neural network. In deep learning, you very well know about neural network. Deep learning is based upon neural network only. Neural networks are it's an architecture, sir, where we do have a layer, and sir, in layers we are having neurons. Okay, these are the layers, and we are having neurons on the layers. That is, sir, inspired by sir biological neuron. Okay, that means like our brain architecture. So such kind of architecture is inspired by that only. Okay, so here we give the input, and every neuron is connected to every other neuron in the network. So it's a dense network. Dense network. Every neuron is connected to every other neuron. Dense network. Okay, and this entire architecture, we call it as a model. We can take the output from here. So we are having input layer, we are having output layer, we are having intermediate layer. So from input, we are going to take the input only. Okay, output, we are going to give the output, produce the output, and here are the intermediate, where the computation is being performed. And what kind of computation, what kind of math has been done here? Y equal to wx plus b, this is the math applied. Okay, we are having a neuron, x is the input, y is the output, w is the weight, b is the bias. So weight and the bias are the parameters. Okay, just like you can relate this equation with y equal to mx plus c. Sir, this is a linear equation, sir. We have already studied in our maths or 11th standards or in linear algebra. Yes, you have already studied. And because of this only, we got like Nobel Prize in physics. Okay, the person who devised this thing, who told this thing about this neural network, this architecture, he got the Nobel Prize in physics. Okay, the work is related to AI, but the Nobel Prize has been won in physics because of this neural network. Geoffrey Hilton, I guess. This is the name of the scientist. Okay, but here we have to deal with the images. Okay, images. So, sir, how such architectures can be built if you are having an image data? What can be done, sir? Okay, image. Here it is. Sir, image is having, sir, resolution. Sir, resolution means width into height. Ah, yes. That is the resolution, width into height. So this will be width, this will be height. And sir, what we have seen is like 512 into sir 512, sir. That's what we have seen, sir, in images. Yes, that is within the height. That means 512 pixels are arranged in this width. Okay, and 512 images are present in height wise, in width wise also, and height wise also. 512 pixels are present. So these are 512. These are also 512. So just like make a complete image. Okay, make an entire image with the number of pixels. We can have a high resolution also. As much as the good resolution is, you are going to see a good quality picture. And every pixel, you very well know that it represents the intensity information that will be represented in bits, and that will be 8-bit format. That's what you know. Okay, so sir, what we are going to do with this image? Okay, you are going to give this image to model. Okay, you are going to give this image to a model. Your model is based upon CNN, convolution neural network. So we are having two things here: convolution and neural network. Neural network, I have already shown you. This is your neural network. That means I am having layers of neurons. Okay, that's what I do have here. Layers of neurons. Then, sir, what is here in convolution? Convolution is a mathematical formula. Okay, it's a mathematical formula. Let's talk about convolution. What it means. Okay, let me tell you. Convolution. Okay, so convolution, neural network, is a powerful type of deep learning model that is designed for processing and analyzing visual data, images. It revolutionized this field of computer vision, the way computers see an image. We can perform image recognition, object detection, image segmentation, many things via this convolution neural network. Convolution is a mathematical operation. That's what I told. It combines two functions. Okay, so it can be written like this. This CNN. I have seen the formula like FG. We do perform dot product between two functions. That's what happens in convolution. Okay, as per the definitions, it's a mathematical operation where you do perform the dot product between two functions in convolution. Okay, so by doing this, it produced the third function, which express how the shape of one is modified by other. Okay, shape has been modified. So I think here f will be your f will be your image function. G will be some operation which you want to apply on image. And by applying this operation over the image, there will be transformation in the image. Image will get transformed. What you want to do by performing this transformation, what you want to extract from this image, what kind of data you want to get from the image. Okay, let's talk something more, sir. All right, fine. So this convolution in context of deep learning and image processing, convolution refer to the process of applying filter, or I would say kernel, to the image, to the input image, to produce feature map. And that's what we do to extract important features from the image. See, image, this is your image. There is a person who is standing here. I'm concerned about this person. I'm not concerned about the background, what is there. I'm not concerned about these things. I'm just concerned about the person. You guys do project, you guys do research, you are available with the medical data. uh, the medical data, you want to perform classification, you want to perform the prediction in that medical data. You should be concerned about where is the information here, what I'm looking forward for in this particular image, from which feature I can get that, okay, this is a cancer, this is not a cancer. Not everything is relevant here. There are some portion, there are some areas in the image which are relevant. So, what kind of maths you can apply to get that relevant data? That is what I am saying. So, convolution is a math which can be applied to get that relevant data from the image. Okay, so what's going to happen here? You will be having an image matrix. There will be a matrix of image. Okay, so sir, we are having resolution of sir image sir 510 512. Okay, so 512 cross 512. This is the matrix of image where you will be having the values sir 101. Okay, let us suppose grayscale. Grayscale is from 0 to 255. Okay, so you will be having the pixel values 254, 130, etc. etc. You will be having these values. I need to apply a filter here. That means I need to multiply this image with this image matrix with another matrix. That's what I need to do. I need to apply a filter. I need to apply a kernel with in operation with this image matrix to get a result. And that result is a feature map. Feature map, that means a matrix of features extracted from this initial input image. See, okay, let me explain you one thing. You do have a data. In general case, when you perform data science machine learning projects, now you have seen this kind of data, Excel sheet. I know if you are been a learner also, you have seen this data, sir. We work on Titanic data, sir. We worked on house price prediction data, sir. So, sir, we are having this kind of data in which we are available with the features X1, X2, X3, X4, X5, X6. We are having, sir, these features, sir, in the data. So, boss, this is structured data. Structured. Something which can be arranged in tabular format. So, this is structured data. Right now, when you deal with the text, when you deal with the images, when you deal with the videos, we don't have structured data. Okay, this is not structured data, image. Okay, when you are available with the tables, then it's okay. Just like CSV file, Excel file, that is structured. This is not structured. There are two kinds of data, structured and unstructured. So, text, image, audio, video, these are unstructured. Then, how you are going to do the interpretation of unstructured data? That's what we are doing. Okay, and let me tell you one thing, linear algebra, that is the base. That is the base of everything. Whether you are doing machine learning, whether you are doing deep learning, whether you are doing generative AI, matrices and vectors. Because in maths, when you can represent the data in a form of a matrix or vector, then only you can perform the operation. If you have an ability to do that, that's what we did. We have represented data in a form of a matrix, that is image we are representing in a form of a matrix, and we want to extract the feature from this matrix. That's what we want to do. That means relevant features, good features, that's what I want to extract so that I can get an information. I want a relevant information from the image. So I am having this matrix, image matrix. I will be having a filter or a kernel. Okay, that's what I will be having. I will operate this with this, and I will again get another matrix. That is a feature map, convolved matrix. That's what we'll say. It is having the relevant information. We have filtered our data. These are called as kernel or filters. Filter your data. Remove unnecessary information. Okay, sir, this we understood, sir. Image you will make a matrix, and sir, that matrix, the numbers will be related to the pixel, sir. Okay, these are pixel intensity. ये क्या है, sir? By what numbers kernel will be made, sir? By what numbers? See, kernel or the filter. You very well know, na? See, you also do perform in your mobile when you click any image. You say, "Arey, it's the image is looking dark. Let me make it bright." So you increase the brightness. What is increasing brightness? There is a matrix. There is a matrix for brightness. That matrix do multiply with your image, that increase the brightness. The result, okay, everything is not like hawa mein, it's not like in air. No, 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 there is a maths. There is entire maths happening. If you want to make a image dark, obviously there is a matrix for darkness also. Sharp, if you want to make a image sharp, sharpness also. If you want to rotate, if you want to flip, everything, there is a matrix. That matrix will be operated over your image matrix, and the new matrix will be formed. Okay, so kernel or filter, that is a matrix. This matrix is having a resolution of, like a shape of 3 cross 3, 5 cross 5, 7 cross 7. Okay, rare. And 9 cross 9 is very, very, very rare. This is rare. This is very rare. These are preferred. Okay, so I will be having a matrix of like 3 cross 3 or 5 cross 5. This will be my matrix to perform the operation over the image matrix. So this will be image matrix. I will be performing the operation over the image matrix. Okay, fine. So why, the question is, sir, why you are taking this odd multiplication, sir? What is the reason? 3 cross 3, 5 cross 5. See, there is a reason. Everything is having a technical reason. See, if I make 3 cross 3, I will be, if I put 3 here, if I put 3 here, there will be a central element. Okay, there I will be getting a central element. Okay, there is a name for it. I will be having some value at the center. Okay, there is a specific name for it. And yeah, anchor. I think I remember this thing. Anchor. Okay, in images there is so much, it's like an ocean. Okay, in artificial intelligence, we are having two branches, text and images, where you do the research. Both are the ocean. Okay, so by taking odd kernel, okay, we can cover the edges, the borders, okay, and also the central pixel also of an image. That is the reason we do take odd kernel. Okay, got it. That's a very important reason. Fine. And then, sir, do we take one kernel? It depends. If I want to perform convolution, okay, convolution, if I want to perform over an image, I will add a layer, convolution, 2D. I will write 64 or 32 or 16 or whatever, and then I will mention the size. 64 kernels, 64 filters I will be taking. These filters will be random filters. See, for example, filter number 1, its value is 1 minus 1 0 0 1 minus 1 1 1 0. Let us suppose this is filter number 1. Filter number 2, 1 1 0 0 0 1 minus 1 minus 1 0. This is filter number 2. Filter number 3, filter number 4. I will be having 64 filters, and your image will pass through all these filters. There will be a feature extraction. Okay, there will be a feature extraction from it. So CNN is a feature extraction technique. That's the baseline of convolution. CNN is a feature extraction technique. It's used to extract the features from the data, and that's what we are doing. That means from the image, by applying CNN convolution, I will be extracting the feature, and then I will make such kind of data, feature data. That feature data I will give to the neural network. So from here, neural network will start. I will show you the diagram, fair diagram. This is what the rough I did. So by applying CNN, how does it works? Let me tell you also. Let me show you here how it works. Now see it properly. Here it is. This is an input image. Here I am having convolution, filters. Filters you will not decide. If you just incorporate a layer in your code, okay, just like conv, convolution 2D, 2D, okay, 2D matrix, and just write 64 comma 3 cross 3. So it will include 64 kernel, 64 filter, 64 matrix of size 3 cross 3. You don't know what is present inside it, what numbers are present inside it. Okay, that will be random assignment. Okay, so that's what you are going to do. And then after passing through these filters, there will be a feature extraction. Then there is a pooling layer. Pooling layer is a dimensionality reduction technique. That means further reduction. Dimensionality reduction. Okay, that's what happens in pooling. So the architectures which are built, these architectures are like you are having an image as an input. We are having convolution layer, pooling layer, convolution layer, pooling layer, convolution layer, pooling layer. This is how you build an architecture. So convolution is feature extraction, pooling is dimensionality reduction. Okay, so if you are having an image of 512 cross 512, it may be getting reduced to a certain shape. It may be like 8 cross 8. As many as convolution and pooling you will incorporate, your size of the image will reduced. But don't reduce it so much. Okay, that's what the skill I said. कि आप ऐसा ना करना 1 cross 1 कर दो. Okay, this is not you have to do. Okay, you don't have to reduce it like 1 cross 1, only one feature is there, one value is there. No. Okay, and there is a formula also that, okay, let me show you. Let me explain more about it. So convolution, I told, that's a feature extraction. It is a dot product. Okay, between two your here they mentioned it's a tensor operation. You can take, just for a simplification, two metrics. One is your image matrix, one is your filter or the kernel matrix. That's what you can take. Okay, and then this is how it performs. Let me show you diagrammatically in this way. Okay, okay, like this. So green is your image matrix, and the one which is moving is your kernel or the filter. So here you took 3 cross 3 kernel or a filter. The image 1, 2, 3, 4, 5. That means 5 row and 5 column you are having. So you are having an image of 5 cross 5. And this is what you are having, a filter of 3 cross 3. So 3 cross 3 is operating over 5 cross 5. Okay, it will first work on this. It will first work on this, and it is element wise multiplication. Okay, element wise multiplication is there. That means in filter, whatever be the element present here will be multiplied to the element present here. It is element wise, element to element, according to the positions. and then overall addition will be there. So let me show you again. I'm having one more diagram for it. Okay, let's get started. Okay, here. So 1 into 1, 0 into 1, 1 into 0. Okay, this is 0, this is 0, 1. 0 into 1, 0, 0, 0, 0, 1. So 1 plus 1 plus 1. The result of this is 3. Similarly, here also, element to element multiplication and overall then add it. That is the result. This is convolved feature. Not a very hard game. It's easy. Element to element multiplication and addition. That's what you are going to get. Okay. One more example. I've already shared the notes. Okay. And the movement of kernel in row and just shifting down, then again row, then shift it down, then again. This is called as striding. This is called as striding. Stride. You can have one stride, you can have a two stride. Stride means, okay, how many pixels you are covering. If you take two stride, that means there will be jump of two. If you take one, that means it will cover everything. So here it is like how much striding we are having? One, one, one. Okay, and if I make two, then it will skip one. One entire column will be skipped and it will move ahead. Then it is two. And if you take high striding, then the size of the image will be further reduced. Okay, got it. So this is how convolution works. So this is our input image and matrix of the input image, and this is how the kernel is operating over it. This is the kernel matrix. So image matrix, kernel matrix, this is the feature map. This is what happens in convolution. Okay, fine. Here are what the results you are getting. All right, got it. So we are having the kernel size, that is the filters. We take 3 cross 3, 5 cross 5, 1 cross 7 cross 7 rare. 9 cross 9 is very rare. Striding is the movement. Determines the number of pixel kernel window will move. Movement, how many pixels it will move. 1 pixel, 2 pixel, how many it moves. We are having padding also. Padding refers to the technique by adding zeros to the border of the image. Okay, we do also sometimes add zeros. Okay, that's also we do. Adding zeros to the border. Okay, for example, here, here, here. Okay, in order to complete. This is called as padding. We do padding in text also. Okay, so adding zeros is called as padding. Fine. And then next what it is? Here. Then number of filters, depth. Number of filters. So number of filters in a convolution layer determines the number of patterns or the features. Okay, so if you are taking 64 filter or you are taking 32 filter, that means they are the different metrics. 32 different metrics, 64 different metrics. Size will be like if you have mentioned 3 cross 3, so that will be of that size only. But what kind of values we don't know. Okay, fine. And here is the formula. Here is the formula. Remember this thing. If this is the input height of the image, okay, h input, height of the image, this is height of the kernel, this is the padding if you have added the zeros to the image. If this is striding, how many times you are moving, you can put in this particular formula, you will get the height of the output image. Similarly, this is the width. What will be the width of the output image? Okay, so if you are having, okay, let me tell you, if you are having 5 cross 5 size of image, and if you are having 3 cross 3 size of filter, so according to the formula, if I apply this filter over the image, what is the resultant matrix? The feature map, it will be the height output will be 1 plus height input. Height input is 5 for the image, plus 2 into padding. Okay, I'm not doing any padding. 0. Minus height of the filter 3 divided by striding. Let us suppose I'm doing 1 pixel by 1. This is the height output, and the width output will be 1 plus again 5. Okay, width is 5 for the image, plus 2 into padding 0, minus 3 is the width of the filter, and again 1. So this will be 0, 5 minus 3 is 2, 2 plus 1 is 3, this is also 3. So resultant matrix will be 3 cross 3. If you apply a filter over 5 cross 5 image, so resultant will be 3 cross 3. So obviously size reduced, feature extracted. Then you have to apply pooling layer. Pooling layer will, it's a dimensionality reduction technique, and what kind of operation it will perform? See here. Let me show you. For example, this is your image which you got after convolution. You can have different types of pooling. In general, we are having max pooling, min pooling, and average pooling. Max pooling, okay, you are having an pooling matrix of 2 cross 2, let us suppose. Okay, let us suppose you are having a pooling matrix of 2 cross 2. Pooling layer is also referred as a downsampling. It's a downsampling technique. It reduces the dimension of the input, decreasing the number of parameters. We decrease the parameters, dimensionality reduction. See, in data, dimension, if you are having so many dimensions, then there is a problem in data science and machine learning that is called as curse of dimensionality. We have to reduce the dimension of the data in order to get the relevant dimensions which are meaningful for me to train my model. All these is happening because of that reason only. I'm extracting the relevant feature, I'm reducing the dimension, then extraction, then dimension, then extraction, then dimension. That's what I'm doing. Okay, so in pooling layer, it select the pixel with maximum value if you are using max pooling. For example, see, if you, this is, okay, this is your resultant matrix after performing convolution. This is what you got, and then you applied pooling layer. You have applied max pooling, and you did mention 2 cross 2. So it will apply 2 cross 2 here, and it will see max pooling. Max means, okay, what is the maximum number present here? So 7 2 4 5, maximum is 7, pick up. Then here, what is the max number? 5 2 4 7, 7, pick up. Then here 3 3 6 4, 6, pick up. Here it is 8, pick up, and make a matrix. This is dimensionality reduction. This is information. This is information. ये नंबर है ना, नंबर ये इंफॉर्मेशन है. This is information. Okay, this is max information which I am picking, and the least information I'm just ignoring. You can have a min pooling also. You can have average pooling also. Average means 7 plus 2 plus 5 plus 4 divided by 4. That will be the answer. 5 plus 2 plus 4 plus 7 by 4. That will be the answer. And so on. That is average pooling. So pooling is to reduce the dimension, and it depends. We use max pooling, we use average pooling. That I will tell you. There is other pooling techniques like global average pooling, which has been widely used now. I'm going to tell when I'm being showing you the project. There I have incorporated the layers. Okay, so there's an advantage of pooling. Okay, so you do create a CNN architecture in this way only. That's the base. Convolution, then pooling, then convolution, then pooling. Extract feature, reduce dimension. Extract feature, reduce dimension. That's what you have to do. Okay, we also use activation function. And the activation function which is used here is ReLU. That is rectified linear unit. Okay, ReLU activation function. ReLU activation function means If you are having a negative value in the input, you will get positive as a result. Okay. So if you are having a negative value, then result is 0, and if you are having a positive value, then the result is same. Just if I made some error in just a previous statement, ignore it. This is ReLU activation function, famous activation function. If input is negative, the answer is 0. If input is positive, the answer is same. That is ReLU activation function. In neural network, we use activation function. Okay, to activate the neurons, to fire up the neurons, to share the information ahead. But in convolution, we don't have neurons. So what we are having, sir? We are having kernel. We are having filter. These are working. These are having a task just like of that neurons. While training a CNN convolution neural network, what happens? Nobody will tell you. The adjustment of kernel has been happened in convolution layer while performing back propagation. Okay, that's what happens. What is training? Training is to adjust. What to adjust? Adjust a parameter. In convolution, what is the parameter? Sir, filter. Kernel. This matrix is a parameter. So we need to adjust this filter or the matrix so that I can better extract the features from the image. This is a technical answer. So you train your no, model. And it has been told to me, sir, in deep learning, we have to train like 100 depots, 200 depots. Why? Why you are going so much in that? Right now, we have to use the algorithms, we have to use the techniques which will optimize your task. So if I do talk about the research, that is optimization. Optimization, okay, reduce computational complexity, increase accuracy. So if you can do this thing, as compared to the previous research, you are in a win-win situation. You have improvised. Reduce computational complexity, increase the accuracy. If your algorithm is able to do that, you have win. You have won. Okay, fine. So this is what happens in convolution and the pooling. And then what you are having next? Once you extracted the feature, perform damage reduction, then there is one layer that is called as a flatten layer. So convolution, pooling, then there is a flatten layer. Flatten layer will convert high dimension to low dimension. That means 1D. It will convert it into 1D. Okay, high D to 1D. So after performing extraction and damage reduction, you will get some this kind of matrix. This matrix will be converted into 1D, a vector. And this vector is having all these numerical values present here. Now next you can give this numerical values to the neural network. You can give this thing to the neural network for the training purpose. So image doesn't comes directly to the neural network. No, it doesn't mean that you are having an image, give it to the neural network. No, unless and until you don't extract the features from the image, don't give it to the neural network. That's okay, you will be having something like, okay, mess. So our pre-trained models are based upon CNN only. These people, these researchers, these scientists have organized the convolution layer in such a way that when they took a data, benchmark data, and when they have trained their model with that benchmark data, and then they have performed the classification over that particular data, they got accuracy 90%, more than 90%. High accuracy they have achieved. That's why we are referring to such kind of architecture. So if you want to learn, if you want to know about computer vision, if you want to go in more depth related to the CNN, okay, the basic architecture which was introduced initially were first one is LeNet, LXNet. Okay, it is having only three layers. LXNet, I guess, is having five layers. So very very basic architectures: three layer, three convolution layer, five convolution layer. Okay, then you are having, okay, GoogleNet. Okay, then you are having like VGG 11, VGG 16, VGG 9. Now from here, the layers increased 16, 19, 42, 51, 101, 152. Okay, layers increased. We are having ResNet 101, residual net. We are having ResNet 152. So layers increased. But it's not like that. They are not fool enough that they can connect CNN convolution, one after one another. No. Because if you do this thing in a sequential, your image get diminished. It will become zero. You have seen na? If you have applied over a 5 cross 5 image, you have applied 3 cross 3 filter, the image is converted into 3 cross 3. When you again apply 3 cross 3, how much it will be? Again reduced. So if you are having 152 layers, what will be the size of the image? They have built a architecture smartly. That image will not become zero. Don't worry. That is the smartness. That is why we are using the pre-trained architectures. And we have to learn these architectures. We have to understand these architectures. Okay, what is the technique they have applied in those architectures? That's what we have to understand. Okay, meanwhile, I got some basic codes for you. Okay, so at least we can have some hands-on related to the medical imaging. That's what I'm having. Okay, I have also shared the code with you. Okay, so if you want to practice initially from your side, you can install a library that is CV2. This is Computer Vision Library. Computer Vision version 2. This is the library, CV2. Okay, and this is for visualization. And I am having a image, just X-ray image I am having. Okay, that is a JPG image. So I read this image. Read means I just opened this image. cv2.imread. This imread is an function which is present in cv2 to read an image, and then here I am showing the image. cv2 color image, cv2 dot color bgr to rgb axis of plt show. That means I am showing the image now. CVT color means convert color. Now listen carefully. Whenever you read an image, that image is automatically converted into blue, green, and red. When you read an image, it will convert into this bgr format that needs to be converted into rgb. So that's why I have used here cvt convert color image cv2 dot color bgr to rgb. However, since my image was already a grayscale image, there is no impact on it. I already told you that you are having the X-ray images in grayscale, but if you want it to convert or access it in RGB, you can do that. Only the thing, the complexity increases. Initially, I am having one channel. Now I will be having three channel. Okay, and the same information will be projected in the three channel. So no need to worry. Okay, I can resize my image also. Okay, let us suppose, sir, I want to change the width and the height of the image and I want to make it like 300, 300. You can do that. This is 300, 300. You can resize your image. cv2 dot resize. That's what you can do. Okay, and then, sir, you want to convert it into grayscale, sir. So that was already in grayscale, but you can do that. You can convert any color image into grayscale by using cvt color.bgr to gray. Okay, color to gray. You can convert it. Okay, this is your image. You can blur your image also. See, in CV2 computer vision library, there are many things, many functions are available. You can blur your image. That is one of the function which I'm using here. That's called as Gaussian blur. Okay, so you will be having certain metrics, and this is 0 stands for the standard deviation. Okay, I have already mentioned some notes related to it, so you'll not have to be in a problem. You can refer to these notes. So I'm taking an image, I am taking a kernel, and 0 is the standard deviation in the x direction. Okay, so it will perform the blur. That means blur means it will soften the image. That means it will, which is often used for noise reduction. Okay, it will make your image smooth. Okay, so this was the initial original image, and this is what your blurred image. I can increase the intensity of blurriness also. Okay, by changing the values, you can change the blurriness. Okay, you can change the kernel. It's up to you. So that is blur. I can perform the rotation of the image also. Okay, by using cvt.get rotation matrix 2D, this is my rotation matrix, and I will apply this matrix with the image matrix. And when I was also doing my engineering, there was one subject called as computer graphics, which I have studied. In computer graphics, we were having one topic, that is transformations. There we did perform 2D and 3D transformation, just like, okay, multiplying the image, one matrix with another. That's what they are doing. Image and the matrix of the rotation. So it can perform the rotation, 45-degree angle. Here I have mentioned no 45-degree angle. You can rotate the image also. And these kind of operations are been done in your projects also to increase the number of images. This is called as augmentation. Changing the orientation of an image is called as augmentation. So if you are having less number of images, you have been instructed, kindly increase the number of images. So you will perform augmentation. Rotate the image, flip the image, blur the image, dark the image, increase the brightness of the image. All these things you do in augmentation. So there are many kind of transformations available. Okay, so the description has been mentioned here. And there is one more thing. I can filter the image like this. This is my sharpen matrix filter. Sharpen matrix, sharpen filter. And cv2.filter take the image matrix and perform the sharpen. Okay, perform the sharpening of the image. Means operate with the image. This sharpen matrix. Okay, so here you are going to get the result. Sharpness increased. Okay, so I am having this matrix for sharpening. Okay, and I'm having image input -1. That means it specifies the output image should have the same depth as of the input image. Okay, and this is sharpening kernel. That will increase the sharpness, and we are displaying the result. So very basic codes I have introduced here, just to show you how we do work with the images. It's not like that, sir, directly jump on to the project and explain. So it will be just everything will be off. Okay, so like these are the basics. Fine. Resize also. I have shown you all these. Okay, fine. So these are some basic codes which I need to tell you, need to show you. Fine. And I guess yeah, I guess I'm having one more code where I've applied convolution, a single layer convolution over an image. This is how you can incorporate a convolution layer. This is convolution layer. 16 filter are there, 3 cross 3 size. This is the shape of the image which you are going to take as an input. And this convolution kernel 3 cross 3, 16 kernels are there. They will operate over this input shape matrix. Width, this is width, this is height, this is channel. One means grayscale. 28 is the width, 28 is the height. One means grayscale. Grayscale image. That's it. Very simple architecture I took. This is how we can build. And we can apply this technique over the image which we have available. Image resize, na? Resize image which we have available above. This is resized image. So I have applied here in the architecture in the model which I have created. So from this features are extracted, and this is the extracted feature which I am getting. Now you can see the depth has been increased 16 because 16 filters are used now. 16 filters are used, so 16 will be the depth. This is extracted feature. Okay, this is the extracted feature shape. Initially, the size of the image was 2828. Now it is 2626. Grayscale image, 16 depth. Okay, got it. So one single I have used convolution. We will be using a lot. All right, fine. So now you can speak from your side. So how was your day one session? Can you please tell me? Now you can say from your side. And it's good that a lot of people were still present with me. I request everyone to stay here. Okay, just stay here only, and if you want to say, you can. Did you understood what we have studied in the session? Okay, I got so many feedback, positive feedback. Okay, yeah, please say. All right.
Yeah.
Yeah, please say, ma'am.
Uh, so for me, like I am coming to this field after like 13, 14 years, I would say.
Yeah,
So
ma'am.
for me, uh, this is really wonderful, and at least I'm looking at what's the scope possible, what research can be done, how the basics can